Welcome to this lecture on variables and data types. Now, any programming language, if you take, it has to allow you to create variables. Now, some languages don't have data types, but in Java, there are data types. Now, variables contain some known or unknown information. You might want to store some name, age. If you have created a variable but not stored the value, the information is unknown. Now, variable name is the way through which you can access the stored values. At the end of this video, you should be able to understand variables and you should be able to explain data types. Let's start with variable. It's a storage location paired with a symbolic name, or what we generally call it as identifiers. Now, why do we need that? We have the memory, it's been allocated, you have stored something, but how can I get that back? Now, some languages allow you to work with addresses, but in most languages you don't have that. So you need a name to that memory location. It's also easier with names because we define that name such as age, city, salary, and so on. So it becomes easy for us to relate what we have stored and what is expected value. Now, these are also called as scalar variables or scalar types. Now, they contain some known or unknown quantity of information. It's also referred as a value. So what is stored in a variable is a value. Sometimes they're also called as the literals. Now, they can be changed over a period of time within the program execution. Now, hence the name called variables because it varies. A variable name is the usual way to reference to a stored value. In Java, there is no access to the actual address, unlike C or C++. And you have something called pointers in C and C++, which you don't have in Java. There are two types of variables in Java. So if you want to create a variable, you need to first decide, hey, is this a primitive or is this a reference kind of variables? Now, why do we have to know about that? Now, it's important to know about this because it depends on where exactly they get created. Let's begin with primitives. Primitives are variables that are created using the Java's built-in data types. There are 8 of them. Each of them are keywords and they're grouped in 4 categories. Let's start with integers. Now, these cannot store decimal values. Even if you store 1.9 in any of them, the storage will only consume 1. 0.9 will be discarded. Byte is only 1 byte storage. Short 2 bytes, int 4 bytes, and long 8 bytes. So the bigger values that you need to store, you move from left to right. If you want to store decimal values, you have 2 types of data types called float and double. They are very similar to that of C and C++, just in case if you know about that. Float occupies 4 bytes. And this is also in some languages called a single precision storage. And double, like the name says, it has a double precision. It is 8 bytes. It can store anything from a mass of an electron to a distance from Earth to Sun. Now, if you want to store characters, now alphabets, symbols, and so on, now we have char as the data type. Now, unlike C and C++, char takes 2 bytes. Now, in these 2 bytes, we can store alphabets or symbols from various other languages. We call this as Unicode. Now, there is another type called Boolean. In C and C++, you don't have the concept of Boolean. A 0 represents false and a non-zero represents true. But however, in Java, you have a type called Boolean. Now, the keyword here is Boolean. Now, you can only store true or false, nothing in this. Now, primitives, memory allocation takes place instantaneously, meaning as soon as the compiler finds a variable being declared, it allocates memory. The size of this memory is already known, we just discussed. Now, size of the variable depends on the data type. For example, size of char is 2 bytes, size of double is 8 bytes. So, compiler is already aware of these things, and as soon as it finds such a variable, just defines that. References, on the other hand, is something new that you see it in Java, especially if you're coming from C and C++ background. Now, declared using a class or an interface or something called enum, or they can be arrays. Now this is in Java. So the size of a reference is fixed, and that means if you are creating a reference that refers to a person object, an employee object, an animal object, an account object, it doesn't matter. The reference size is always frozen. Now typically the reference size is 8 bytes, but it depends. Java language specification does not limit a compiler to have certain number of bytes, but it's more or less 8 bytes in most of the compilers. Now references, when you create a reference variable, it is always initialized to something. Now it is initialized to an object or a null. So it's not same as pointers in C++ or C. Pointers are nothing but addresses. We can manipulate that address. Given a pointer, I can say, let me go 10 bytes away and grab that information. We can't do that here. Now the only thing that we can do is get the reference, delete it if you don't want. Now a reference can be used as method arguments, meaning you can supply that references, and you can also get them as return types. They can be assigned to another reference of the similar type. So you can take an object, there is an object of shape, let's say a circle, and you have a C1, C2, C3, you can assign C1 to C2 or C3 and so on. But you can't take that circle object and assign to an employee object. So there is a data typing involved. Now cannot be used with operators such as arithmetic or relational operators. So you can't really take an employee reference and say, let's add 20,000 to this. Not possible. Now you can't compare also. Let's see how to create references. Imagine a class called person, and we have two variables here, P1 and P2. The way you can create an object in Java is you say new and person. So what you can see here is an expression. Now on the right hand side of the equals, you have an expression that is supposed to create an object, meaning allocate memory, initialize and all this stuff. Now you take that, get the reference, assign to P1. Now until this, there is no memory allocated. If you ask what is the value stored in P1 and P2, you won't get anything because it's not initialized. But after this statement, P1 contains a reference number. Now we may not be able to get what is that stored in that, but through that we can reach to the person object, manipulate the values in that. Now for example, I want to store age of this P1 as 44, you just assign to that, access its property and then do that. Now P2 equals to P1 is where we are now taking the reference from P1 and assigning it to P2. At this point in time, how many objects do you see? Now there's only one object, but you can see both P1 and P2 refer to the same thing, which means if I say P1 equals to null, now the number of references are 2, number of objects is 1, but how many references are referencing to that object? Only P2. Now, P1 has been initialized to say, hey, don't point anywhere. If you assign null to P2, now you are disconnecting P2 and the actual object that it was pointing to. Now what happens to that object? There is nobody referencing to that. Now this object now is called as an abandoned object or a discarded object. Now in general languages like C and C++, this would have caused a problem called memory leak. Now in Java, there is a feature called garbage collection, which is an automated process of cleaning up all the abandoned objects or discarded objects. Now that's a big relief from the developer's perspective. So I don't have to keep track of how many objects I have, how many I have cleared, and I don't have to really do that. Now let's summarize what we have seen so far. In this particular video, we understood what is a variable, how exactly you create them, what types of variables that exist in Java, such as primitives and references, what are the different primitive types we have, and primitives are static memory allocation, references can be used as method arguments, and return types too.